This is video 21, learning about serialization with concise binary object representation. The code for this video is at the GitHub site. These videos on MicroPython should work as well on any MicroPython board. All code examples have definitions at the beginning of the file to allow the user to alter as needed. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. In this video, we continue from video 15 by learning about serialization with concise binary object representation. We will look at some background history of CBOR, then we will install the CBOR2 on our desktop and a similar library on our MicroPython microcontroller. We will verify its ability to encode on the desktop and decode on a MicroPython microcontroller. Finally, we will briefly talk about tags. Let's jump forward in time and watch the demo. I found inserting the UART Bluetooth module and starting the microcontroller first, then the Python program on the desktop to be the easiest connection. On the monitor at the left screen is the desktop program running in the Visual Studio Code, and the right screen is the microcontroller running in Thony. For this demo, I configured 3 message types: the hello text, a list of values, and thirdly, a list including date time and time zone value. The last message is an example using the CBOR2 tag feature, and I will show it later. Okay, first we'll press a button on the microcontroller. Notice that the message is binary and concise. The desktop decodes the message value without needing the schema. We can try it from the desktop by pressing the letter D. And the microcontroller decodes the message. Now let's try the second message. Notice it encodes and decodes on the desktop without needing the schema. Let's send it from the desktop by pressing the S button. And the microcontroller is able to decode it as well without the schema. Now that we know that CBOR works, let's learn more about it. CBOR is an acronym for Concise Binary Object Representation. It was originally published in 2013 as RFC 7049, and a new edition became available in 2020 as RFC 8949. It was developed to provide a compact binary message that can be decoded without a schema similar to JSON, but avoid JSON's need for base 64 encoding for keys, graphics, and sensors. And the data format is extensible. For more information, see their website, which is included below and in my acknowledgments at the end. That website provides links for more than 20 language implementations. For Python 3.9+, there are 3. We will only utilize the main CBOR2 implementation as it states it supports for RFC 8949, whereas the others mention only RFC 7049. A Google search located a MicroPython library that also states it is based on RFC 7049. Although I suspect its version is slightly before version 1.2 on the desktop. So we'll see more about that when we need to use tags later. So my first thought is, can I exchange messages between a desktop using CBOR2 and my microcontroller? Here is a summary of the packages and the UART BT module I'll be using. Here is the wiring from my STM32 microcontroller to the UART BT module. On the desktop, I opened the settings to learn the COM port for my classic Bluetooth connection. Here you see it's COM port 5. Let's look at the code. On the desktop, I opened Visual Studio Code on a virtual Python 3.11 environment because it supports the latest CBOR2 release. and I installed Keyboard to attach keyboard keys to send messages. Also noticed that I installed PYTZ, which is for time zone support that we'll discuss last when we talk about tags. On the microcontroller, I downloaded from GitHub the MicroPython CBOR files, and I copied the entire unzipped CBOR folder to the flash folder. Both the desktop and MicroPython test program files can be downloaded from my GitHub site. We can see these programs are very similar to the programs I used in video 15. In those examples, the program starts up waiting to receive bytes serially. It captures bytes until it has a complete frame and then decodes it. So in this section of the code, I'm waiting to receive data, and once I get it, I print it out. And on the desktop, you'll see I've set it up so that keyboard commands will send messages. So in the first example, setting the hello message, I use a variable for the hello message itself in byte format, put that in a list called message, and then use the CBOR2 dumps to encode the message. I then print this out, as you can see below, and send the message. On the microcontroller, there's a very similar set of code. There's a section that receives the message and decodes it, and then I've set up buttons to handle the messages. So the first button will create the hello message, put it in a list, then use CBOR to dump it, in other words, to encode the message, and then it will send that message. Again, when I press a button, in this case I'll press the first button on the microcontroller, it's going to take this hello message, encode it, and send it. So here's the encoded message. It's not very tricky. So if we look at the second example, when I press this button number 2, you'll see, sorry about that, I pressed it twice, but you'll see that here the encoded message is a little bit more obvious. You've got the 4 different objects encoded in this long string, which is 18 bytes. And it's easily decoded on the desktop. All right, let's look at the third example. So in the third example, we're going to use datetime. Datetime is coded differently on Python and MicroPython. So tags are used to provide a means to extend the data format of CBOR, in our case, datetime. Let's look at the code to add datetime to the message on the Thony. You'll see that I'm building the message as before in the second example. However, I'm picking up the date using the RTC method on the microcontroller. I then parse out the year, month, day, hour, minute, and second from the microcontroller. Now I want to put it in a format to send serially to the Python desktop. So I put it into this string. Now this whole string is then uses the tag method of CBOR, and it's going to use the CBOR0 tag, and this is what is sent to the Python desktop. Now this has got a newer version of CBOR, so it knows what to do with tags, and it will just decode it without any issues at all. So let's try and send this message. Now I'm pressing the third button on the microcontroller. and you'll see that it's included the datetime. So here's the readable datetime, and then here below it is the encoded version. It's a lot longer, 46 bytes, but that's because I have a long datetime timestamp. And over here on the desktop, it converted it just fine. So it received that encoded string, and it decoded it using this datetime time zone conversion. So here's the code on the Python desktop to send it to the microcontroller. So here I'm using the PYTZ module, using the time zone for New York, which is the time zone that I'm in. And I've created a DT variable that has both the datetime now and the time zone. I'm going to put that in the message and send that to the microcontroller. And I'm going to do that by pressing the letter T on the keyboard. Except for, I'm going to press it down here. Okay, so we've pressed the letter T, and it's here's the message that's readable. So you can see that it's converted the date time into a value that it sends to the microcontroller. And the microcontroller, as you can see, knows that there's a tag here, and it knows that this is tag 0, and here it has the date time from the desktop. So it works. So in this video, we learned about a better serialization package called CBOR2. We installed it on the desktop and a microcontroller, and we transmitted messages. Finally, we learned a little about CBOR tags. I hope this video helped. Thank you for listening.